Hi friends, now we are going to learn optimal tree problems, Huffman tree and codes. In greedy method, right, we are going to discuss Huffman code and why it is required. We can see that there is the optimal tree problem. Remember the tree problem is what? As we are knowing that trees are cyclic graph, right, and the number of edges will be one less than the number of vertex. But why it is called it as a optimal, right? So when you are going to construct trees with the help of Huffman concept, right, of encoding, then that particular tree is what you are getting as a outcomes. It is a optimal trees. Clear? Now, why this Huffman code is and what is Huffman code is? Remember earlier days that there was telegram service, right? And what it happened there is person is going to send some text from one place to other place, right, by encoding some informations. So maybe A can be written as a dot hyphen dot, B can be written as a hyphen hyphen dot, kind of things, some symbolic. Okay, so that is called encoding part. Now there are 26 letters, say as for example 26 letters in a small case or capital letters, you can say that in English alphabet, and each and every letters if you give the equal values, right, of encoding, right, say all the input you are going to write it in 5 bits, right, then what will happen that each and every input, each and every A, whether A is also required 5 bits and Z is also required 5 bits. It means when you are doing the encoding for say example, right, greedy, say we are going to do encoding of greedy, G will have 5 letters, E will have 5 letters, right, E, E, D, Y, 5 letters. Then 1, 2, 3, 4, 5, 6. Greedy, all 6 letters can have 6 into 5, 30 bits in encoding form. Okay, that is called fixed length coding, right? But as you are knowing, some of the letters in English alphabet is going to repeat more number of times, right? Say as for example, A is repeating more number of times, E is repeating more number of times in vowels, in consonant S is repeating more number of times, T is repeating more number of times. Hence Huffman coding says that rather going for the fixed length coding, I can go for variable length coding. Variable which is repeating frequently more number of times, we can give lesser encoding bit, such a way that overall length of encoded bit will be lesser. So that is why these Huffman coding concepts came. That is why this Huffman trees concept came, to decrease the encoded data, length of encoded data, by applying the concepts called variable length coding based on frequency, or we can say the probabilities of those input. So idea is to assign variable length codes to input character. Length of the assigned codes are based on frequency of corresponding character. Either we can say the frequency of corresponding characters, or even we can perform the task for probability of given character. Variable length coding assigned to input characters are prefix code. I will tell you with an example. Means the code bit sequence. Remember that when I said you that A can be represented encoded in the form of 0 or 1, right? As you are knowing that computer understands 0 1 form, binary bits. So all A, B, C, these all characters must be written in binary form with the help of 0 or 1. Right, so we'll get the pattern if you are saying that 0 1 0 0 is A, then B should not be the same. Not even any other character should have the same binary code as A. Remember that code will be unique, and based on the algorithm called Huffman coding, always will get unique code, right? Yes, are assigned in such a way that the code assigned to one character is not prefix code assigned to any other character, as I said you, right? Fine. So remember that this Huffman code is lossless compressions algorithm. It means what? If you are saying that compared to fixed length coding, we are able to use less number of encoded bits. It means what? We are going to compress the data. We are going to make more optimal, required less amount of space, right? I believe all of you got that. What is the fixed length coding and variable length coding? Say as for example, here we have A, B, C, D, E, right? And say all A, B, C, D, E is having same length, called, I am talking about the fixed length encoding, right? A is written as a 0 1 1 0 0 1. Similarly, B is written as 1 0 0 0 0. C is written as 1 0 0 1. D can be written as a 1 0 0 1 0, and E can be written as 1 0 0, right? We can say that 1 1. If you see that pattern of all bits are different, all represent unique letters, and all are having the fixed bit, right? Fixed length means all are having the 5 bit. Now someone is wanted to encode called say bad, right? So how it will go? B, what is the form of B? B can be written as a 1 0 0 0, A can be written as a 1 0 1 0 1, and D can be written as a 1 0 0 1 0. Look, this is encoded form. This is called encoded. This is called plain text. All of it try to understand. This is called plain text, bad. This is called encoded text. Encoded text, right? Or you can say encoding bit, right? Or you can say that cipher text, right? Remember, encoding bit means what? Nobody should read that message, right? So a moment you are sending any mail from one place to other place, source to destinations, that informations will get encrypted such a way that nobody should read. And how it is getting encrypted? By using encrypted technique, encrypting algorithms. So here Huffman coding also, after encoding, will get all information in binary bit only with the help of Huffman. So now Huffman coding is done with the help of following steps, right? Remember that calculate the frequency of each character in the strings. If it is a string or sentence, we are going to calculate the frequency of each and every character. If it is in probabilities, then no need of finding the frequency, directly you can perform the task. I repeat, if input is given in the form of a string, then you are going to calculate the frequency of character. If it is given in the numeric form, maybe direct frequency is given or probability is given, then we will go and proceed with the final process given by Huffman tree algorithms. right? And what is algorithms? First of all, you are going to sort all the characters in increasing order of frequency, right? So we are writing their character and what is their frequency, and based on the frequency we are writing all the input in ascending order, lesser frequency first, larger frequency at the last, right? Similarly, make each unique character as a leaf node and create empty node x, assign the minimum frequency to left side of the child x and assign the second minimum frequency to the right child of x. So basically we are going to form a trees from the root. Left of root will have lesser values, right of root will have, means generally left child will have lesser values, right child will have the greater values. We are not talking about the binary search trees. In a given frequency, always you are keeping left side lesser values, right side greater values, right? And sum of these values we are going to write it into the root values, root level, right? So let us see that how you are going to perform the task with an examples, and we can understand that how exactly your Huffman coding is works, right? So we are going to implement these all points one by one, and finally you are going to perform the task. So remember, this information is very important. Call assign 0 to the left child and 1 to the right child, and encode all leaf node character from leaf node to root node, right? So let us see that how you are going to perform the task. Say we are going to discuss, right, road is good. Example, road is better, right? So we have set of characters. Now you are going to find the frequency of these characters. Okay, so one by one you are going to find the frequency. We are going to write R, right? So this is the character and you are going to write frequency of that character. R, how many number of times is repeating? 1, 2 times. So frequency is 2. O, next character is O. O, how many times is repeating? Only 1 time. A, how many times is repeating? Only 1 time. D, how many times is repeating? Only 1 time. Blank space, remember the blank space is here character. So we need to take care of blank space. 1, 2 times. So blank space generally we used to represent in a square block, right, box. So we can write 2 times. I, 1 time. S, 1 time. B, blank space already considered. B, 1 time. E, 2 time. E is 2 time. T is 2 time, right? Remaining all is taken care of. So first you calculated this frequency. What is next job? Next job is to arrange this frequency in ascending order, right? So how will do that, friend? First lesser frequency values you are going to write. 1, A 1, D 1, I 1, S 1, B 1, right? Thereafter larger frequency is R, R 2, E 2, blank space 2, T 2, right? So there are 4 characters of frequency 2. We have arranged it. Now concept says that add 2 minimum frequencies values and make a trees, keeping in mind left side will be the lesser values, right side will be the greater values. Here 2 minimum values is O and A, both is having the same values, not a problem. So it is like we are saying that O and this is A. And what is the values of 1 plus 1? 1 plus 1 is 2, right? So this is the frequency. Even you can write like this. right, letters and frequency of that letters here. 1 plus 1 is 2. Now if you see that 2 minimum, this becomes 2. Ideally these things, if you are going to sort it again, this will go after 1. This will go after 1. So what is the next minimum? These two already computed. This is over. So D and I will be the next minimum values, or S and B will be the next minimum values. So next iterations we are going to, next iterations I am repeating it, right. This work is over. Again you are going to resort it. If you are going to resort it, what will happen? Resort. If you resort, what will happen? D will come first. D1, I1, S1, B1, right, and of course these two will go later on, right. So we have either these two we can put it over here, or we can keep it at the last. It is up to you how you are going to do it, but answer will be different if you are keeping here at the between, or you are keeping at the last. But nothing to worry, here we will not have only one answer, we will be having multiple answer for this kind of questions, but your process to be correct. Now we will keep it this. We have a 2 unit, left is O, right is A, and both are 1 1, right. Look, we did it. We sort it again. Now we found that this 2 is having minimum values, this 2 is having next minimum value, D and I, right. So we are adding this D, I, and we are making 2. Similarly, if you see that previous informations, D and I is done, then we have S and B is also having 1 1, so that also we can add it, right. We have S and we have S and B. S and B. This is also, it is 1, this is 1, this is 1. Now I feel like that all are 2 2 unit, 2 2 2 2, this is also 2, right. So next iterations what will happen? These 2 and 2 will get added, R in left side on blank space in right side, both are equal, so we can do anyway. So R and blank space. We have 2 plus 2 is 4, we have R and we have blank space is also 2. Similarly, E and 2, E and T. So we can go and E and 2, E, T. So E is also 2 unit, this is also 2 unit, 4 unit, E, T over. Based on the previous, we have 2 unit O and A, we have 2 unit O and A. You will see that these all are in ascending order, right. Till now we have completed 1 2 3 4 5 6 7 8 9 10. So you should have that 10 values only, 3 4 5 6 7 8 9 10. All right. Now select 2 minimum and add it. Look, 2 2 2 4 4. So first 2 minimum is lesser values, will add it. So what will happen friend here is, we get 2 plus 2 is 4, and here we have, say it is a node, and left side is O, right side is A, right. Similarly, Another side of 4 is this 2, left side is D and right side is I, right. So 2, 2, 4, this 4, 4, this is 2 is minimum. So either these 2 can be joined with 4 or these 2 join with 4 or these 2 will go with another 4. Any 4 we can join these 2 because first 2 minimum elements if you are going to consider, we can sort this 2, 4, 4, this 4 will come at the last, right, hence these 2 becomes minimum values, right. So just we can write it now, we have a 4, ET and T and we are writing here 6, keeping smaller values in left side, we are keeping 2, here is the S, keeping right side B, right, and here is a 4 parts, so here we have R and here we have a blank space of 2 unit. Okay, so unit if you are not writing also later on there is no issues, we are not worry about this, right. So basically this is 2 plus 2 given 4 and finally it becomes 6. Out of this now 4, 4, 6. We know that first 2 minimum we need to add, so these 2 is the minimum values and both is having 4, 4. So either this will be left side or this is going to be the right side, not a problem. We are going to get the similar answers, right. So if you are going to join this, how it looks like, next iterations, we are going to join this, while joining it looks like 4 and 4 becomes 8. 4 and 4 becomes 8. Now we have a 6 and we have a 8. Ideally, based on the algorithms, a smaller element will be the left side and larger element will be the right side. Left side, right side. So smaller is left, 6 will come in the left side. But we should be careful while we are doing this. Now we are having 8 plus 4, 8 plus 6, 14. Left side we say that 6 part will come, right side 8 part will come, right. And we are going to rewrite these all information. 6, we have a 2, 4, okay. We have a 2 and we have a 4, right, 2, 4. SBR box, SB, this is S, this is B, then R hash, R, this is blank space. Similarly, for 8 you are going to copy, we have a 4 and 4. We have a 4 and 4. Then this side we have a 2 block OA. Here we have a O, here we have a DI, here we have a D and here we have a I, DI. So this is basically 2, 2, right. Now if you see that right side we have 4 ET, right side we have a E T. You can observe that value of frequency of the letters was 2, right. So this is 2, this is 2, this is 2, this is 2 are very close to root node, very close to root node. Okay, I will show you once. Look here, frequency of letter 2 is R, blank space, E and T, right? So these all are original values of R, blank space, E and T are close to root node, close to root node, right? Our frequencies having lesser values 1, they are very away from the root node. While we are constructing the Huffman trees, make sure that left informations will be the lesser than the right. You can see the left is 6, right is 8. Here left is 2, right is 4. We need to do, if both are same, no problem. Both are same, no problem. Any values you can keep it either left or right. Till now what we have done, this tree is called Huffman tree, because we have applied concept of Huffman algorithms, but it is not completed. It is Huffman trees but not Huffman code. For Huffman code, what we are supposed to do, we are going to allocate each and every edge, right, either 0 or 1. Each and every edge we are going to place values called 0 or 1. How? Left edge we are going to place it 0, right edge you are going to place it 1. Labeling will be uniform. All the left edge compared to any root, subroot values will be 0. Labeling all the right edge compared to root node must be 1. So with respect to 14, this is left 0, this is right 1. 6, where left is this much, right is this. Left 0, right 1. 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 Right? We have done it. So this is basically called labeling. Right? Then only we can write these all in the form of binary bit. Now remember that these all letters must be on the leaf node of the trees. That is what called Huffman trees. Right? We are not worry about this part, we are worry about these letters. And we are going to read these informations from root to leaf node. Right? In that case, if you are going to say here, remember that this we are going to read from leaf root to leaf node side. In that case, if I am going to tell what is the value of S, S is here, you read from here 0, 0, 0. So what is S, friend? S can be denoted as 0, 0, 0. Look, 0, read 0, read only binary bit from root to leaf node 0, 0, 0. Similarly, what is the B? 0, 0, 1. What about R? 0, 1, 0. 0, 1, 0. What about blank space? 0, 1, 1. 0, 1, 1. Similarly, what about this O? 1, 0, 0, 0. What is O, friend? 1, 0, 0, 0. See, 1, 0, 0 is O. A, 1, 0, 0, 1. What is A? A is 1, 0, 0, 1. Similarly, D. We are talking about D. What is the value of D? D can be written as 1, 0, 1, 0. 1, 0, 1, 0. I 1, 0, 1, 1. 1, 0, 1, 1. I. E can be written as 1, 1, 1, 1, 0. What about T? 1 1 1. So we will see that when you are reading from root to leaf node, right, we can convert these all character present in sentence or in the form of a string in a binary form with the help of Huffman coding. So this all coding is very much unique from one to other. There is no, two characters will have the same binary bits. And one more thing we can observe, a value which was very far from the root node is having 4 binary bits. Okay, 4 binary bits. And value was having frequency more, having the less bit. Right? Frequency more, less height, less bit, less number of bit. And frequency lesser, okay, more number of bits in binary form. Right? That is why this tree is called optimal binary trees. First of all, each and every node having the 2 child node, maximum of 2 child node, and since it is optimal, it will take lesser amount of binary bit, required number of binary bits, hence it is called optimal. I hope you people understand this, and with the help of this we can even code and decode. So now question was, road is better. Road is better. Input message was road is better. So we are going to see that what is road? R 010, RO 1000. So R is 010, 1000 for O, right? ROA 1001, 1001. What about D? D is 1010. D is 1010. Blank space 011. 011 is blank space. What about I? I is 1011. I is 1011. What about S? S is 000. S is 000. Again we have blank space. So we can see that blank space is 011. 011. B, we can see that B is 001. 001. E, we can see that E is 110. 110. T, T is 111. T is, so double T, 111, 111, double T, 111. Again we have E. E is 110. E is 110. And we have R is 010. R is 010. So this is plain text. This is encoding bit. This is a plain text message. Okay, now we have converted this complete message into binary bit, right? This is Huffman coding. This is Huffman coding. Maybe sometimes they will ask you by using this character to decode it. They can ask you decode something, right? Decode, say I can write some message, right? We can write some message that we can see that how we can decode it. By using these characters, we will write some another message, okay, and we will try to decode it. Look friend, sometimes they will ask you, they will give you the binary bit and they will say, okay, now you can decode it. Okay, what will be these informations, this bit of informations, what message it can give. So how we are going to do it? By seeing this, you take these bits and go and compare with our input. Where is input? This is the input, right? So see, certain bits start from 0, right? Some are start from 1. So we focus on that and we start extracting the values. So let us see that. What is the first value? First is 0. How many are starting with the 0? You focus on that. So starting with the 0, these 4 are starting with the 0. So maybe one of the answer. After 0, what letters? After 0, what letter? 1. So after 0, 1. So we see that out of this 4 0, after 0, 1 is 2 possibilities, either R or blank space. So 0, 1 is common. What is the third bit? After 0, what is the third bit? So third bit you can see that it is a 0, right? 0 1 0. So here will come 0 1 0. So this is 0 1 0, right? And what values you have? It is a R. So we are going to say that this is R, right? Now from here you can see that 1 0 0 1 start with 1 but followed by 0. So go and see that start with 1 followed by 0. This is 1 0 0 and 1 0 0, right? 1 0 1 0 1 0 1 0. 4 cases we have, because this last 2 cases is 1 1, so fail. 1 0 1 0 1 0 1 0. So let us see that how many are having 1 0 0. Thereafter go and see that 1 0 0 is matching already. What is after 0? After 0 again 0, right? So 1 0 0 after 0 again 0 means these 2 again fail. Now we have options only, either this or this. So 1 0 0 1 0 0. After 1 0 0, what bit we have? I bit 1 0 0. Again we have 1. So let me see that. What is that? 1 0 0 triple 0 is O. So we are going to take this O as a final answer. So we are writing here RO. Now 0 0 pattern, 0 0 double 0 triple 0 pattern we need to check. Double 0 triple 0. So it is double 0 double triple 0. So 2 0 3 0. So there we have a 3 0. So it will be S, right? So this is S. Now 1 1 0. Let us see that where is 1 1. This is not 1 1. After 1 0 0 is there, fail. These all are start with 0, fail. After 1 1. After 1 1. So this is what? After 1 1. Right? So double 1 is 2 case we have E and T, but what is the last? 1 1 0. So in that case 1 1 0 is E. So our final answer will be E. So like this we can decode, right, from the given binary bits, So we can encode or we can decode, but in both the cases what is mandatory is to construct this Huffman trees. That is very important. Now Huffman coding is used in conventional compression. I said you that why compression? Fixed length coding is taking more amount of space, binary bits or any other encoding characters, but Huffman codings take lesser amount of bits. So we can use for the compression technique, as we have a gzip, bzip2 and pkzip etc. Also use this text and fax transmissions, right, to perform things faster, right. So this is all about Huffman code. Even we can solve the problem Huffman coding based on the examples, like we have say character and we have say probability of character. Say we have A, we have a B, we have a C, we have a D and we have a hyphen. Say probability of A in a dictionary is repeating more number of times. Let us give 0.35. This 0.2, C is repeating more 0.25, right? So it is already and here you can say that it is 0.15 and this is 0.5. So if we'll add this sum of probabilities, you know that it is 1, so probability will be 1. 2 plus 2 is 4, right? 4 plus 6, it is 10. So what you are supposed to do in this, little bit I will give you the hints for this problem also. First we are going to sort this in ascending order. So what is the minimum frequency? Hyphen 0.5. Next is D 0.15. Next is B, it is 0.2. Thereafter C 0.25. Then we have A, right? We have 0.35. So this probabilities we are having it. But what is the rule says? Huffman tree algorithm says that first you add minimum frequency, minimum probability. So these two are minimum frequency, minimum probabilities. So we can join like this. Hyphen and D values you are joined it. And what is sum of frequency? 0.5 and point. So it is 0.2. 0.2. So now it is 0.2. Adding these two probabilities, this is 0.2, this is 0.25, 0.235. Among this 0.2, 0.2, 0.25, 0.35. First two minimum is these two values. So next iterations what will happen? We are going to join these two values. So maybe we can write 0 plus 2 plus 2, it becomes 0.4. And left side we can have 0.2 of left side hyphen, this side we have a D, this side we have a B, like this. Now we have 0.4, here we have 0.25 and here we have a 0.35. Which letter are going to combine? C and A. Keeping in mind that C value is lesser, A is greater, so C will be left side, A will be in the right side, right? So how it will go? We are going to add 0.35 and 25, it becomes 0.6. C will be left side because it is has lesser frequency, A will be in the right hand side, has a maximum frequency, right? 0.25, 0.35. Now look here, sum of these two values, again you got 0.6, this is already added with this and we got 0.4. So now it is 0.4, right hand side we have 0.6. So we are going to perform the task that 0.4 will be left hand side and there all the values will be here in this part. That is, this is a B value, this one is a hyphen, this is a D value, probably that is the values, yeah, right. So now Huffman trees, one step is pending, that we can join it, and here we have values 1 probability 1, left all the values we assign with a 0, right 1 0 1 0 1, and we can see that what is the value of A? Value of A is 1 1. What is the value of B? Is 0 1 0 1. Value of C is 1 0, and value of D is 0 0 1, and value of hyphen is 0 0 0. That's it. Now someone is asking you based on this problem to encode bad hyphen cab, bad cab. So what will happen in code? We can encode B. What is B? 0 1. What is A? 1 1. What is D? 0 0 1. What is hyphen? 0 0. What is C? 1 0. A 1 1. B is 0 1. However, bad cab is encoded with the help of Huffman trees, right? So this is happened because of we gone through the proper process and constructed Huffman trees, right? And here also you can see that one thing is very common, that hyphen and D is very far from root node, and hyphen and D is having 3 bits, remaining all is having 2 bits. Reason is hyphen and D was having lesser frequency, if you would have noticed, right? Hyphen D was lesser frequency means more number of bits. More frequency, more probability is lesser number of bits. Okay. So this is all about, and both the examples is very important. This is all about your Huffman trees, optimal binary trees, right? Thank you very much.